All right, welcome everyone. So this is going to be our second week of the second semester. You can have these videos watched before we arrive in class. We're going to be looking at lessons 83, 84, and 85. So lesson 83, multiplying numbers in scientific notation. We know scientific notation, we're working with powers of 10. Okay, we have to remember the rule when we're multiplying anything that has the same base. Again, our base is our larger number. The exponent is the upper right-hand corner. So the base for this would be 10, and 10, the exponents would be 3 and 4. When we're multiplying, we add the exponent. So 3 plus 4 is 7. So we have to remember that concept. When we're dividing, we subtract, which will work with dividing scientific numbers as well. May not always be positive. So if we look at example 1, the first thing we need to do is multiply our coefficients. 1.2 times 3 gives us 3.6. 10 to the power of 5 times 10 to the power of 7. 5 plus 7, since scientific notation is always base 10, that makes it easy to remember. It's never going to be anything else. So we're adding the exponents since we're multiplying. Again, multiplication we can do in any order. So even though they're not next to each other, we can still multiply and apply these properties. So 5 plus 7 is 12. So we're left with 3.6 times 10 to the power of 12. We just have to make sure that our coefficient, this number right here, is greater than 1 and less than 10. So we can't have like 36 times something. We have to make it 3.6. In this case, it worked out. We didn't have to do that. Some we may have the added step. So let's look at this. We have 4. Let me do it. But if we have 4 times 10 to the power of 6 times 3 So we're multiplying these two scientific notation numbers. Our coefficients we can multiply. 4 times 3 is 12. Then our base 10, 10 to the power of 6 times 10 to the power of 5. 6 plus 5 is 11. Now, we don't want it to be 12 because that's greater than 10. So this looks correct. If you put this on a test, you're going to get half a point wrong because there's one extra step that sometimes we have to do, but not always. So we need to make this 1.2. So I moved the decimal over here. That's essentially dividing this by 10. Well, if I'm dividing this by 10, then I need to multiply this by 10 in order to keep it equivalent. So in multiplying this by 10, or 10 to the power of 1, it's going to give me 10 to the power of 12. So I may have that last step. So if it was 0.12, I'd have to multiply by 10 and then take 1 away from the exponent. In this case, I divided by 10, so I need to multiply by 10 or add 1 to the exponent. And so it just kind of depends. If we multiply those coefficients and it's less than 1 or greater than 10, we're going to have that one extra step at the end. And we can think of 12 as 1.2 times 10 to the power of 1, which we just did. So we're essentially adding 1 to the exponent when we move the decimal to the left. Now we may have negative exponents. Nothing wrong with that. We've been working with negative numbers, negative exponents. The same properties still apply. So 2 times 3 is 6. 10 to the power of negative 5 times 10 to the power of negative 7. Negative 5 plus negative 7 is negative 12. Again, if you struggle with adding or subtracting negative numbers, you can use a calculator just to make sure it's correct. Negative 5 plus negative 7. So some people that are getting thrown off by that and calling that negative 2 or positive 2 or something like that. We're negative 5 and we're going 5 more to the left. That puts us at negative 12. 5 times 10 cubed, 7 times 10 to the power of negative 8. 5 times 7 is 35. So we know we'll have to do something with that in the end to put the decimal in between. Base 10, we have 3 and negative 8. So 3 plus negative 8 is negative 5. And then I move the decimal over to make this 3.5, which means I add 1 to the exponent. Negative 5 plus 1 is negative 4. Okay. Right, we'll go over those practice set problems when we get to class. I think one of our last videos got cut short, so I'm trying to make sure it doesn't boot me out of our own meeting. Lesson 84, we're looking at algebraic terms. Okay, so what is an algebraic term? Well, let's look at some polynomials. Again, poly just means many, so polynomials, it could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 terms. Some of the more common ones, a monomial is just one, mono, one. Binomial, bi, two, tri, three. Trinomial is 3 terms. So this would be an example of 1 term, 2 terms, 3 terms, then 4, 5, 6, 7. So polynomials is kind of the general term, and then if it's just 1 term, monomial, binomials, which you guys will work a lot with down the road, even trinomials as well. We usually want to write it, again, since we can add in any order, we can rearrange these in certain ways, but usually we write it so that way the term to the highest power is the furthest to the left, and then work backwards from there. So x squared, negative x, and then our constant, or just our number, if there's anything there, that's at the very end. So the term, okay, the number, and the variable. Okay, there is no variable with this. The variable is x. Variable here is x squared, and then constant, as we said, that is just a number at the end. Like terms, we've been combining like terms all year, but if we see something that says simplify or combine like terms, what we're doing, any terms that are the same, meaning not necessarily that the number, the coefficient's the same, but the variable and it's to the same power. So xy squared, not y squared, xy squared and xy squared. Okay, well, x times y to the power of 2, x times y to the power of 2. Those are like terms. Now, if it was x squared y and xy squared, those are not the same terms. And so we can't combine them. So if we have this, and again, since we can go in any order, we have 3x plus y plus x minus y. So I can do 3x plus x, or plus 1x. We don't write in the coefficient, but we know it's 1. I have 3 of something, I add 1, I have 4x. I have y minus y. I have 1 of something, I take 1 away, I have 0. So I'm left with 4x plus 0, or just 4x. Okay. So for this one, again, must be like terms. So 3x plus 2x squared. I cannot combine those because this one is x to the power of 1, even though we don't draw in the exponents, x to the power of 1, and this is x squared. A number and a number squared are not the same thing. That's like saying 5 and 5 squared. No, those are 2 different numbers. So x and x squared, 2 different numbers. So we can't combine them. But I can combine 3x minus 1x. So I have 2x. 2x squared plus x squared, or plus 1, gives me 3x squared, and then 4 minus 1 gives me 3. And then I rearrange those. What I'm left with is 3x squared, since that's the highest value, the highest degree. I want to move that furthest to the left, x squared, and then x, and then my constant. So 3x squared plus 2x plus 3. Okay, so we have it listed in descending order. It's not that if we had 3 plus 2x plus 3x squared that is necessarily wrong. It's just down the road when you get into trinomials and quadrilaterals and things like that, it's going to make it a lot easier if we just get in the habit of writing it in descending order. All right, we will go over these again, terms, combining like terms, when we get to class. And then the last lesson for this week. Oh, there we go. Stay. Okay. Lesson 85, order of operations with positive and negative numbers. Again, there's nothing in the order of operation that says, oh, well, if it's a negative number, then all of a sudden it jumps to the front of the line. It's still order of operations. We're just going to have some extra steps when it's negative numbers. Again, I don't love how they put in the parentheses +2. If we did that in our calculator, we would get an error message, but they just overemphasize which numbers are positive and which numbers are negative. And I think it makes it more confusing, but they're just trying to show you this number is negative or this number is positive. And I would probably just put 2 instead of parentheses positive or +2. I would just put 2. But anyways, that's just kind of my own preference and something I don't love about this book. But we have -2 plus -2 times -2 minus -2 divided by 2. Okay, so order of operations, I have multiplication, division, addition, and subtraction. So I need to multiply and divide before I add or subtract. So -2 times -2 becomes +4. -2 over +2 becomes -1, but then I'm minus -1, so it's going to become +1. So -2 plus 4 plus 1. So -2. Again, plus 4. That just looks weird, and you do this in your calculator, it'll give you an error message because we don't run signs right next to each other. But either way, here we get 2, -2 plus 4 is it's +2 plus 1 or minus -1. 2 plus 1 is 3. So it's 3, or +3. Okay, this one we have parentheses. So 2 minus 4 would be -2 times -3 would be +6. This one we have -2 times -3 is +6. So times -4 is -24. And this one is -3 times -4, which is +12 divided by 2, which is +6. So if we kind of break it apart, we had 6 minus 24 plus 6 right there. Then once we have it to where it's just all addition or subtraction, we know how to work from there. So 6 minus 24 is -18, plus 6 is -12. Again, the commutative and associative property, we can move numbers around as long as it's the same addition and subtraction at the same priority level. So we can move those around as needed if it helps us. So again, sometimes it's easier to move numbers around in order to help us kind of calculate or simplify. All right, so example 4, simplify. Well, 3 times -2 is -6. 2 times 4 is 8, so -8. So -2 plus -6, or -2 minus 6, -8. Minus 8 gives me -16. We'll have some in there with absolute value and different things. So tip that I would give, I know one of the first questions I get is, oh, well, how do I do this in the calculator? How do I do this in the calculator? I would not do an entire expression like this in the calculator. We can, it's just between all the multiplication and addition, we're going to have to use brackets, braces, parentheses, and everything to make sure that it's following order of operations. Sometimes we can put something into a calculator where we see it in one way, but the calculator is going to calculate in the way that it's set to. So the order of operations that we're intending for it may not be what the calculator is reading. And I'll show you what I mean by that when we get to class. So I would do, you can do how they kind of are broken here. Do this in your calculator, hit enter, and then write it down. Okay? Do this portion in your calculator, hit enter, and write it down, and then do this portion in your calculator. Not that we need to, but if you need this to kind of, for comfort level, to do some of this, break it down into chunks. So we're just multiplying, well, we're subtracting and then multiplying. Do that in your calculator, you'll recognize it, no problem. Do this in your calculator, -4 times -2 times -3, no problem. -3 times -4. I would do that and then hit enter, or do -3 times -4 inside parentheses, because again, it's in the numerator. That's its own group symbol. So I would just make sure that you do that. Put parentheses in your calculator. So you do -3 times -4 divided by 2. Because sometimes we put these, like I was showing you guys when we do averages, we add 5 numbers and then divide by 5. If we just add 5 numbers and then hit divide by 5, our calculator does the last number divided by 5 and then adds all the other numbers unless we use parentheses. So just a little side note, if you're getting a weird number, something that doesn't make sense, punch it into your calculator. Okay, you may have to break it apart. Okay. So that is it for this week. We'll see you guys in class. Bring any questions that you have, and we'll go from there.